limited area models. Christopher will present. There's a list of authors, himself, Celeste Saulo, Anabor, Camponagara, Chaburó, Silva Dias, Freitas, Garcia Escabar, Machado, Nascimento, Nicolini, Pulido, Ruiz, Salho, Santos, Salcedo, Stockler, and Vendrasco.
We need this. Do you send that? Do you? Can you? Is this loud enough? Can you hear me? That's okay? No, it's alright. It's alright. That. Do you think that is working with that? You can. Thank you very much. Well, good morning, everyone. I will present to you this pilot project, this initiative, which is a high-resolution limited area modeling ensemble. So it's a collect, okay, of models of multi-boundary, multi-model ensemble with very high resolution, 2 kilometers, that was taken during the Santa Maria campaign. Okay, this is more like a telling story presentation. So I don't have conclusions. I mean, hard conclusions indeed. Well, why to do it? The motivation. It started related to activities of another project, a research and development project, which is related to WMO activities. And the objective was targeting high impact weather over La Plata Basin. This is an initiative. It's an ongoing project, still ongoing project. There is a collaboration among Dr. Celeste Saulo, Dr. Alice Green, and myself, in order to solve this problem. That there is a deficiency in the La Plata Basin. In order, the models cannot resolve, they are not good enough to solve high impact weather. Well, there are other reasons, obviously, to do ensemble. Ensemble matters to chaos. Chaos is inherent to weather forecasts, no matter the scale. So far, the ensemble is more known as a tool to predict the large scale, but also in very, very fine scale, you have also the chaotic behavior. Okay, so the scale involving high impact weather are much finer than the current global APS. So we need to initiate tests to feel this, to have a feeling about how is the behavior of ensemble modeling. There are similar initiatives since the end of the 90s in North America, short-range ensemble forecasting, and Europe, short-range ensemble prediction system. So they are ahead of us. And obviously, liaison, connection with the activities of the Shuba project. Okay, the objectives of this pilot project mainly was to assemble a pseudo-operational system during the Santa Maria campaign, where we composed an ensemble system using ensemble prediction system, large scale, and also high resolution models. Okay, assessing the forecast skill, which I will not show in this presentation. We will have further presentations that will show forecast skill. And obviously, since it is a pilot experience, learning from the experience. Okay, we start from the end. This is how, here it's written front end, this is how the user in the page in the SOS Chuva Sul could see the products. Okay, so it's a very nice, very fancy feature, very front end. When we have here, you have a menu. Okay, where you could select the your models. Okay, you could select your initialization time, and also you could select your forecast lead time, your forecast lag. Okay, up to 36 or 48 hours, short range. And then you get this, the result was the model selected for the lead time predicted in this panel. Okay, when you had this position in layers, you could add layers with radar, with any other features that you have, and transparency adjustment and zooming, very nice, very worky. And I have to thanks to Cynthia Freitas and Mario Figueiredo. They collaborated a lot to realize, to accomplish this. Well, the members configuration. How was the concept? CBTech EPS, the global system came from EPS, okay, not from deterministic global models. That's the main difference. So we had the CBTech EPS and CEPS, and we had to add, as an idea from Eder Vendrasco, to GFS deterministic. So the larger scale was provided by these models, by this EPS, Ensemble Prediction System, and we had the finer scale, the very high resolution here, provided with by BRAMS and WRF. So we have 5 members in a core system, 2 times 2, plus GF coupled to WRF. They were synced, they were conceived to be homogeneous in domain size, horizontal and vertical resolution. So this is, I call it the core system, homogeneous in these characteristics. But we have also external collaborations from these other models, these other partners. But they weren't able to be seen in this previous panel, okay, in this previous tool. Only these five configurations. So since you have the lateral boundary conditions provided by the EPS Ensemble Prediction System, you have to choose what we call the representative members. So I had to decide one, just because limitations of size of disk space. I had to choose only one member, okay, from the CPTEC EPS, and only one member from GFS EPS. So I use this premise. The ensemble mean, we know that the ensemble mean is the most likely scenario to occur. So how I cannot use, it's not physically consistent to use the ensemble mean. So I had to find the member which is most likely, most similar to the ensemble mean. So I developed a simple method based on spatial similarity, spatial correlation, okay, between each member and the ensemble mean. Those special correlation, special similarity, they were ranked in the first 48 hours. So I could have also a score in time, okay? So here I present a result for the first 6 hours for the CPTEC EPS. This is ensemble mean. You can see that there is a diversity of features. This is the region where the spatial correlation was taken. And you can see that the spatial correlation displayed here. For the first 6 hours, so the member choose for 6 hours, for the fixed 6 hours, was this one in this case, because this is the highest spatial correlation. 0.96, okay? Then you do subsequently the same for the 12 hours forecast leading and start to rank, and at the end you will have an index that will give you the selected member. Okay? Another work that was developed was related to intercomparison. In the same menu, you could display the station data, okay, if you market this option. So then you have the model and plus then the location of the stations. If you click in one of the selected stations locations, you will have a graphic like this where you could see simultaneously all predictions given by this system. WRF, GFS, Brahms CPTEC, Brahms NCEP, the ensembles, the global ensembles itself, themselves, okay? So you can do the comparison. This is a work that was inspired and also used the technology, the hard work, made by Moreira and collaborators, which is probably is a system that is already known by most of you. It is here at the IAG and also there at CIVITEC. Then we have to adapt what is in the backstage behind of this, and we have changed a little bit the appearance of the display. Okay, so you could simultaneously compare like this situation, the forecasting for precipitation, okay, among every model. There was another product that was part of this project, which was provided kindly, was TIGI contribution, which was provided kindly by Mio Matsueda from Japan Meteorological Agency, and it's based only on global ensemble prediction systems. Okay, so the idea here is the probability of extreme 24-hour precipitation, and you have the combination in here and individual ensemble prediction systems. What you are seeing is the probability of the precipitation exceed the climatological curve. Okay, so that's the way that you see this. And one conclusion that I will better say at the end, this is a very useful product. Resources spent behind all these fancy features, very nice. We have to spend resources of this order: 7.3 daily gigabytes from NCEP EPS during the period of the Santa Maria campaign, from the beginning of November up to almost the end of December. Total 370 gigabytes. From CPTEC EPS, this was downloaded from the internet. This one we run itself. Okay, we spent 3.5 terabytes, 11 terabytes from the high resolution model with 2 kilometers. The 5 members in here, they are all storage there at the CPTEC facilities. Many hours of supercomputing, CPU, 3 machines, different. 5 different accounts, more than 20 people involved directly or indirectly in the backstage, in the background of this little initiative. So, to finalize, just some thoughts. I said at the beginning that we didn't have any conclusion, but in general, the product, the TIGI product, is nice. Is a very fair product to estimate extreme event. Not the exact localization, but if some extreme event will occur in advance, with 7 or 8 days in advance, which is a medium range, a very fair medium range. CPTEC PS does not belong to this product, but I could subjectively estimate that it also is able to anticipate the main events, the main extreme events during the Santa Maria campaign, also with this lead time. Okay, high resolution assembling is a resource consuming activity. Hence, this must be well planned, you know. And I would suggest, this is only the tip of the iceberg. I would suggest to continue to go deeper into this project, this initiative, to study better, because we are well behind. The other partners. In the Northern Hemisphere. Thank you very much.
Thank you. This is an initiative that's I think we are all very proud of, because it took lots of organization. Christopher was ahead of this, and with the Argentinian partner, Celeste, and others. And basically, we learned how to do it. So now the thing can be improved. I welcome questions.
Just one comment that for Manaus would be very nice.
Thank you very much. I appreciate it. I was thinking, indeed, to do it, to continue with the activity.
Any comment? Questions? We have the other chair of the session here. Please, Gilberto.